So we're going to make a solar cooker. The idea is to make a solar cooker that works well, insulated solar electric cooker, ISEC, that is appealing to consumers. So we want it to look and function like a little oven. It's going to work a little slower than an oven, but it doesn't need coal and nuclear and frac gas. It just uses energy straight off the solar panels. So we're going to manufacture our own burner. There's a lot of flexibility in how you make these burners. In this case, I'm going to make one. This one is going to become that one, but it's going to start out as just plain old sheet metal. So in this case, I want a 1-inch flange. I'm coming up 1.5 inches, down 1.5 inches on that side. So that's 1 inch, 2 inch, plus 3 inches. That's 5 inches, right? 3 and 2, 5. Yes. I just measured around. It's about 27.5. That measurement doesn't matter exactly. It's something in that neighborhood. So this is duct metal, 26 gauge galvanized sheet steel. It's pretty cheap, pretty available in a relative sort of way. And we're going to run it through our big shear. And the thing with the shear is it's a big heavy scissor. So we want to make sure we keep our scissor in good shape so we keep our metal clean. So we wanted 5 inches, is that right? 5 inches. So I'll make a 5-inch mark. I'll make a 5-inch mark. Now the really cool thing about this shear is it's really fast to get a nice, clean, even cut. You can use the fence. If I'm doing one cut after another, I use the fence. But sometimes if I'm doing a single cut, I just make marks. I can see the marks where the blade's going to hit it. And then a hole, keep your fingers out of there. Watch your toes. Boom. I just cut that. 27.5. Zoom. Square mark. Doesn't have to be super precise. Now, anytime you're handling sheet metal, but especially once you start using these hand shears, you get sharp, sharp edges. You can get needle sharp edges right on that. So you either want to wear gloves or you just want to be really careful. I mostly just try to be careful. Now this particular burner I made kind of rectangular shape. I think I'm going to stick with that shape. So it's 5 inches by 8 inches. Curious measurement. Don't know why I did that, but that's the way I'm going to do it. So we just make marks at 5. 5 plus 8 is 13. Plus 5 is 18. And 18 plus 8 is 26, I think. Very nice. Marks. Mark. Mark. Allows me to very quickly make 1-inch marks. Okay, now we're going to flip it over and put a mark right in the middle. And in this case, we don't need a long mark. That 5 inches. I hate crummy tape measures. The significance on the mark being on the opposite side, you'll see when we put it in the sheet metal brake. The brake is the bending tool. We'll bend this thing up into that shape. So we're going to fold this thing around. So on the inside corners we need to cut out a notch, and on the outside corners we just need to cut it. So any little piece of right angle material will mark our notch. And it's not super precise anyway. Okay. You can see how you want to come up with efficient methods of doing this. Because for any of this stuff, there's going to be, now this last one, I want to cut differently. This is just going to be a tab, so we'll cut it like that. A corner right here, and then on the opposite side, we're not cutting corners, we're just cutting slots. I'm just making cuts like that. And then right here, we cut out this part. So that's what we end up with. So we're going to turn that into this, and then into a burner. It's called a box and pan brake because it's got fingers. The fingers allow you to do boxes and pans, so you can go around these corners. This is a cheaper brake that does similar things, but it doesn't have the fingers. So what we do, we pick these levers up, we line up our lines, like so, and we lock the lever down, and we come up. And that makes a fairly nice right angle. In this case, both levers all the way up, right back into there, come back down again. Come up again. Now, reverse it. This is the reason the marks are on the other side. The center mark. We're going to try to come down right in the middle of that center mark. And then I'm going to go beyond 90 degrees, throw it all the way over. Then, so that's what we've got so far, and it's a little wonky, but that's okay. Wonky means not perfect. Then we can use the brake to finish the seam. Another crimp or two. There. Not so bad. That's what we're looking for, kind of a T-shaped thing. We use our punch. This is a Roper Whitney number 5 Junior. Punch. So we grip right on that line, fold. Grip on that line, fold on that line. it's all a little crooked, it's okay. It's sheet metal. Sheet metal can be persuaded to do what you want it to do. Darken up that mark a little bit. Hopefully those holes will line up more or less. We'll see. This is a pop rivet tool. You don't have to use pop rivets. You could use sheet metal screws, even wire. But I like the pop rivets. They're fast and easy. Pop that together. And then you put in your next pop rivet. So that's what you're aiming for. You saw how we made it. We take our punch and we punch 4 holes. Boom, 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 all the way around. And then we take a block of wood as wide as this, and we're going to screw this down. We're going to punch 2 bigger holes there for the wires to come out. These wires have an insulating sheathing on them, this material. So we have a high temperature wire with a high temperature sheathing on it. It comes out through those holes. So what's happened with this one's already been assembled. We put some cement down, some refractory cement. Refractory cement comes in big old bags like that. This brand name is Heat Stop 50. It comes as a powder. It looks like that. Now this already has, you don't have to put sand in this. This is already everything but the water. So we took this tray, we screwed it down, and we filled it up with about that much refractory cement in the bottom. We ran in our drywall screws, and then we used our nichrome wire, nickel chromium. In this case, this is a 48 volt burner, so we got 64 inches of nichrome wire. I'll do the crimp on the wire in a minute, because that's different tools. But after that cement had dried, so we let it sit a day, the screws are in there, I can come in and I can weave my wire back and forth from those screws, and that puts a bunch of strands of nichrome wire. And then I can add some more cement just to hold that nichrome wire in place. You got to make sure these wires aren't touching each other. Put a couple of little blocks in here to help hold it in place. And then this can come out. And then this can come out. There. See? Separates from the piece of wood. There's our nichrome wires. You could leave it like that, but I think it would actually look much nicer. So we're going to mix up our sequence a bit. So we went from a piece of sheet metal until we made a little box, 4 holes for the wires. Then I'm going to put this one, shift the drill back into forward, connect this back down to the wood. So we've got our Heat Stop 50. You can use Portland cement if you want. If you want to use Portland cement, you're going to need Portland cement and sand. This stuff basically already has the sand in it. Then, see, we're looking for something about that thick. You know, a little thicker, a little thinner, it doesn't matter. So we don't need a lot. We just need enough to protect the wires. Take this, just vibrate it. That burner is complete. Wires are fully covered, they're not touching each other. Now we can put some, we can go back to this burner, which is not fully complete. We'll need some more mortar. Put some in the tray. And we'll run some screws. Okay, in this case we've already done the math. We know that we need 64 inches of this nichrome wire. And I'm going to give myself 65 inches because of the overlap in the couplings. 65-inch piece of nichrome wire. So this is high temperature wire. Cut off a piece about so long. Another piece, same length. A couple of pieces of high temperature wire, wire strippers. Twist it up a bit. This substance is soldering flux. We're going to solder these joints. In the earlier cookers we were making, we were just crimping them, and we found that those crimped joints were failing. So not only are we soldering them, but we're actually using a high temperature solder, not an electronic solder. A lead-based electronic solder is not going to hold up very well either. Get one end of our nichrome wire. So the nichrome wire is going all the way through the coupling, and there's a bunch of soldering flux on there. Then we're going to crimp it. In this case, I'm not so worried about the crimp being perfect because we're also going to solder it. Soldering flux. Make sure it goes in the coupling. That wire goes in there. Make sure it goes through. Crimp to hold it in place. And this is where we get to use the torch. Oh boy. I'm going to set this wire up where I have access to it without touching it. Now if you have a little soldering iron, that works would probably be a little more elegant than this big old torch. But the torch will work. Now, if these were high voltage wires, I would not be treating them this way. But this is low voltage. We're going to have an extra insulating sheath over them besides that. So I think they'll be okay. Just look and make sure that solder got down in there where I wanted it to go. I'll cut a bit of this stuff. This is a high temperature insulation sheath made to do exactly what we're doing with it. So we're going to feed this through one of these holes, like so. So my insulation sheath comes right up to the edge of that nichrome wire. So the intention, the purpose of this burner design is to come up with something that's something we can build more quickly. When we do the burners with lots of little beads, we've got to fish the wire through each bead, and it's kind of slow and annoying. With this one, we did the screws, and we got our wire, we soldered the wire, we got the heat protective sheathing on our wire, which I'm going to try to adjust a little bit because I want it a little bit further up. So that helps protect our wire coming through the metal. And then to get the wire in here, we can just really simply and easily go from screw to screw to screw. Make sure the wires aren't touching each other. And then, so we can set something in here, and we can just space these wires, make sure they're not touching each other. Alright, you can lay down a little bit of mortar. Now you'll notice this mortar was just done yesterday. The old mortar is still kind of soft. When you put a cement product on top of a cement product that's only a day or so old, the new cement will bond very nicely to the old cement. If you wait a couple of weeks, it doesn't bond as well. We can just put that down. We can adjust our wires a little bit. Make sure nobody's touching anybody else. There. We can just let that dry, and that'll hold the wires in place. And then we'll pull the screws out and put another layer of cement, and that's the final product. So it's a few steps, but if you lined up a few of them so that you had one at each stage of production, you could use your mortar and go across and do a bunch of them and do them fairly efficiently, and make burners with longer pieces of wire where the wire doesn't overlap. So these are 64-inch pieces of wire for a 48-volt solar cooker.